Thank you very much for joining the call. This is the call for participation webinars for PLP fine pitch substrate inspection methodologies, phase 4. My name is Ria from iNEMI. We have 3 chairs, Fensu Joe Zilfa So, Charles Reynolds, and I will introduce these chairs later on. Agendas. First, I will introduce the project chairs, then briefly explain about the new project development process. Then I pass to Fan. Then he will shares and introduce this project overviews. Then I will explain how to join this project. Please mute your lines during the presentations. We will have a Q&A session after that. Oh, the project chairs. Let me introduce the 3 chairs. Fensu from the IBM. He is a senior technical staff members and also members of IBM Academy of Technologies. He has a lot of experiences of the semiconductor technologies, especially quality management and supply chain operations. His current role is the Chief Architecture for Supply Chain Quality Systems. And the Dr. Joe Zilfa So from Intel, he's a principal engineer. And the expertise is the semiconductor technologies, especially on the substrate manufacturing, methodology, inspections, testing, quality control, and 3D packaging. And the responsibilities of 3D packaging R&Ds and next generations methodologies. And the Charles Reynolds from IBM, he's senior technical staff from senior technical staff members, and he has many experiences on the packaging technologies, especially designs and development. His current focus is on CSP development. This is the iNEMI new project development process. There are 6 steps. Step 1 to 6 is open for industries, and anyone can propose or suggest the new concept of the collaborations opportunities. Then we will move to the next step, definitions and plannings. Then this initiative teams will develop and document the SOWs and the PS. After the iNEMI technical committees approve the concept initiatives, then we move to the next step, launches, execution, and closures. Step 4 to 6 is only limited to committed members from the iNEMI member companies. So we are now between the step 3 and the 4. We plan to kick off this project around the end of February. We have 2 governing documents for project. One is the SOWs, statement of work. It sets out project scope, grant purpose, benefit, and outlines. Another document, project statement, PS. This contains the information management and processes as to secures the contributions to the project. So that we asking the participants to sign this PS and returns to the iNEMI staff. Again, the iNEMI project requires the iNEMI memberships. If your companies are not the iNEMI members, then please contact any iNEMI staff and please discuss about iNEMI memberships. Now, project briefings, I'll pass to Pen. Do you want to share your screen?
Yes, yeah, let me share my screen.
Okay.
So, Surya-san, can you see my screen now?
Yes.
Okay. Hey, thanks everyone for joining this corporate participation webinar. So let me going through some of the background and details of the proposal projects, right? So first of all, the project background. So as Tuyasa mentioned, this is phase 4. So we have complete 3 phases of project. And actually we started back in 2016 with phase 1. So back in 2015 or 2016 timeframe, so actually IBM proposed this project to iNEMI as an industry study because we do see that finite space less than 10 micron, especially going to 2 micron and 1 micron, right, is going to drive, and actually it's going to be required, right, for the industry to go into the high density circuit patterns and layers, right, to support all the new requirements like heterogeneous SPI packages, right? So in phase 1, we start phase 1 as the survey, industry survey. So we wrap up a survey in 2017, right, February, with a list of recommendation and findings, right, from the industry. So with that, we move to phase 2 with some actual inspection capability study based on 2 test vehicles, same design, but one is a glass-based test vehicle, the other one is silicon wafer-based test vehicle, and the pattern we designed, right, in the test vehicle is from 10 to 1 micron nominal, 9 space, and with 10% to 80% purposely designed the mouse by and the metal protrusion defects, right, in the test vehicle. We will have some photos from phase 3 to show you, give you some better idea. We complete the project in phase 2, right, in February 2020. Then we move on to phase 3, which because we get some good results and some good findings, recommendation from phase 2, but we knew that it's not really simulate the 100% the real situation because we don't have warpage, right? Much warpage in glass-based and silicon wafer-based. So we start phase 3 in March 2020 with the actual organic substrate TV with the same design from phase 2 and phase 3, and we complete that in September last year, right? So we do have other reports, right, internal reports for iNEMI members for the 3 phases, and we also did several publications in ISEP conference and EPTC conference, right, on the results from the 3 phases. And one thing is that just to highlight for phase 2 and phase 3, we did get I would say quite a list of contributors in terms of doing the inspection study for us, right? There are many the AOI equipment companies. We also have a few substrate suppliers, right, to joining this. So they are not actually the project member, but they are, we call the inspection contributors, right, to our projects. But I would say one thing we couldn't achieve in phase 3 is because the test vehicle, right, in phase 3 didn't resolve the 2 micron and 1 micron design due to some process limitation, right? So we want to repeat phase 4, right, focusing on the less than 5 micron because the data from phase 2 and phase 3 shows that the industry probably have a very good handle from 10 to 6 micron, right, inspection. So we're going to focus on 5 micron to 1.5 micron test vehicles, and we will also, as I will going through details, right, on the project plan. We also try to repeat, or I would say revamp the survey, right, do a survey again as part of phase 4 because the last survey was done in 2016. It's about 6 years now, right? So we really need to find out what's new in the industry and to see whether we probably definitely will need to up the design from phase 2 and phase 3, but we want to use the survey results as the inputs as a guideline, right, to how to update the test vehicle design and defects design, right, into phase 4. Just a little bit background on AOI measurements. I'm pretty sure most of you are very familiar, right? So optics, light source, alignments, inspection policy, and filters, right? They are the top 5, I would say, elements, or yeah, for AOI equipment system, right? Especially just to highlight that we're not going to do much about AI at this moment, right, in the project, in the scope, but we definitely will including the question about AI, the training of using AI for inspection policy and filter, right, in the survey, at least in the survey, to understand how the industry is moving from rule-based algorithm to AI models, right, to detect the defects and to do the classification. And a typical manufacturing, right? AOI, the results of AOI is really used for a couple of things, right? First, defect detection, right? Means you find a defect in trace, means that product it's a lack of quality, right? Also, the measurement of the space and 9 space, right? Because that's your design spec, and you need to apply SPC, right, onto that too for OCOS. Also, post-processing is that how we've been using the data from the inspection, right, for your process control, for your process fine-tuning, right, feedback to your process, and generates reports, right, and the EO, right, all this stuff. Yeah, so as I mentioned, right, AOI, or Tsudasa mentioned, AOI measurements is really a critical tool for us to ensure the quality and the reliability of the products, especially when we move to an industry, move to 2 micron and 1 micron, right, design regions. Yeah, so this, as I mentioned, right, this is a sample of phase 3 results. You can see this is the mouse bite defects, right, we get from the phase 3. So you can see actually we get 7 companies. Most of them are the AOI equipment companies. They did the inspection for us, right, from 10 micron down to 3 micron, sorry, 9s. And also we have the results from the measurements, right, not the defect detection, but the measurements of the 9 space. We're using Whitecode as the golden measurement data, right? Then we compare the 2 times AOI. We ask them to repeat twice, right, the results to see what is the variation and distribution, right, from the measurements, accuracy of the measurements compared to the golden data, right? So probably in phase 4 we will continue using this kind of comparison methodology, right, to compare the data, right? But then let me move to the some details of the objective of the phase 4, right? So for phase 4, we actually will have, as I mentioned, we're going to focus on 1.5 micron to 5 micron design, and this is the design drawing of the test vehicle we use for phase 2 and phase 2 and 3, right? You can see that we are kind of repeating, right, these 2 micron, 4 micron, 2 micron, 1 micron, same pattern but shrink in the size. So we're going to update this design based on the survey, right, the feedback survey. So so actually we have 2 steps in the project. First is to do the survey to understand what changed from the previous survey results, and whether they have a new what is some typical design patterns, right, in the new design, and what are the defect types that are of interest, and as I mentioned, right, how AI is going to play in the space. Then after the survey, on phase 2, we're going to update design and find in-kind contribution supplier to produce, right, to fabricate the test vehicle for us. Then we will repeat the same capability study, right, with all the companies. So most of the companies that helping us on phase 3, they have expressed interest on phase 4. So we don't really see that's an issue for us to do another round of inspection study. All right. So and for iNEMI, when we have iNEMI projects, right, we always have this easy and it's not analysis, right, for each project. So this is a summary for phase 4. So again, right, this project is to evaluate defects at intermediate level, right, in build at the organic laminate materials. We're going to review the measurement capability by different companies and test vehicles and provide the technology readiness, right, for the inspection, right, for fine pattern circuit boards, and create some recommendation for industry. And we are not going to do the following things, and which means that they're out of scope, right? It's not about developing inspection equipments or technology, right? So it's using the existing one from industry. We're not going to quantify anything, right? It's not like iNEMI is going to qualify or IBM going to using this to quantify anything. We are not going to develop any specs, and we are not going to bias towards any specific suppliers, geography, or market. And we're not going to involve any, or we say in this project we are not design or determining how we do the process, right? And we are not doing any reliability test on test vehicles, right? So as I probably touched this before already, but let me just going through again, right? The proposed detailed experiment plan, right, for phase 4. So as I mentioned, we're going to have 5 to 1.5 micron dimension, and we also, our plan is to add the test nets in the test vehicle, so we can do some e-tests to correlate with the defects. We at this moment we don't know what's going to be the material, because it really depends on which the supplier, right, who wants to do this for us, and it really depends on their existing, I would say, either production or engineering process capability, right, to see what material they will give to us, and in particular we may not really know what's the material, because for example phase 3, right, the supplier didn't even share the details of the material, means the stack material to us, which is fine, because we respect that is their trade secrets, right? So so after the fabrication, we will perform the test vehicle verification, will largely done by IBM, right? We has been do this for phase 2 and phase 3. So we're going to verify the test vehicle, right, with CM, SAM cross section, right, for dimension verification. We also perform the warpage measurements, right, before we ship the samples to other companies for measurements. Inspection company, right, as I mentioned, we got 7 or 8 companies, right, in phase 3. So we believe most of them will come back to help us on phase 4, right. Then we will figure out how to do the e-test correlation, right, along the projects. The schedule, as I mentioned, we have 2 main steps, but here we kind of break it down to 3 steps, right? The first step is still the survey. The second step is to design a test vehicle, right? And of course, the key thing, right, task 2.2 will be evaluating the test vehicle fabrication capability, means that whether we can secure a supplier. So our target is try to wrap up this within 3 quarters, right, when we start the projects, which means that by October, November this year. Then we cater another, based on our experience in the past, right, phase. We're going to cater roughly a year, right, for the test vehicle fabrication, verification, and the inspection starting, and we'll publish a summary. So we'll try to wrap up within 2 years, but in the plan, right, we cater some buffer, right, so which means that we're going to take about 9 quarters, right, to finish the projects. Resource and the risk, at this moment, right, we already confirm IBM, Intel, Unimicron, AT&S, and IBM will join the projects. So and as I mentioned, right, inspection contributor, which are the 7 to 8 equipment manufacturer from phase 3, we will engage them back to the phase 4. The risk is on the test vehicle itself, right? I mean, the design risk is no. We have the existing members already have a good handle and resource, right, to do the design updates. And the inspection risk is no, because we know, as I mentioned, right, most of the company in phase 3, right? The inspection company will come back. The challenging is really on the fabrication of the TV sample. So we has been starting working, right? Although we haven't kicked it off, the existing member already started working to see who, right, in the industry, the substrate supplier can produce this for us. So just in case, right? Just in case, once we finish the design of the test vehicle, then we turn out that we couldn't secure, or there's no supply ready for 2 micron, 1.5 micron fabrication, right? So we would put the project on hold and do some periodic review, maximum every 6 months, right? At the maximum to every 6 months until we find a capable fabricator, right, to continue the projects. So that's the only risk we see at this moment, right? May derail the projects. Okay, so that's all I have. So I will pass to Surya-san to talk about how to sign up the projects.
Thank you, Fan. Let me explain how to join this project as members. Again, that iNEMI membership is required to join the project. So if you are not sure your company is whether the iNEMI members or not, then please contact any iNEMI staffs. And we have iNEMI web pages for this project. I will send the document later on. Then you can visit these web pages from this link, or you can go to the iNEMI home pages. Then you can find out this project web pages. Then please download SOWs and the PS. Then please check and confirm about the outlines and conditions of this project. Then if you are interested in this, the joining this project, then sign the PS, then send back to me. If you have any questions, please contact me or any the iNEMI staff or Fan. Okay, then if I move to next page, then it's now the Q&As. Please unmute yourself and ask questions if you have any questions.
Masahiro-san, this is Steve Martel. I like to be, connected to this right now, but as you know, last time we did not complete it, so but I can try and push again from our side. Okay, this is from Nordson TI.
Thank you.
Okay.
Thank you, Steve.
Any questions, comment?
Yeah. And Joe, Joe, anything comments from you?
No, yeah. Not specifically. Maybe yeah, we do. Maybe this file can be forwarded to other company, right?
Yes.
Yes. Feel free to forward to some other people, other company, for this file when we went through this and send out. So please have to, inform others. Thank you. Yeah, we do, as we just talked about, right? We do encourage some people, if we know some company is going to make the 2 micron, 1.5 micron trace width on the organic substrate, please trying to find out. That is the risk we are taking. We trying to, as a friend just pointed out, we are not able to secure the manufacturer so far.
Thank you. Alfred, can I make one comment? Sure. From the last night webinars? Everyone, the last night we had the one webinars for. Then we got the comment from the attendees. He suggests about the 3D measurement, including the trace height. Then we will discuss it, with the initiative teams the next week. But it is the good input. So the plan is to include the AOIs, the machine's capabilities, the status in the surveys, as we mentioned that step 1 is to conduct the industry survey. So And survey will ask about the capabilities of the 3Ds, whether that would be the possible to capture such, the height variance or width variance on the 2 microns, 1.5 the design rules, the patterns. Okay. Any questions from the attendees? If you would have the questions later on, then please again contact me. I would like to pass your questions to the chairs or initiative members. Okay. And if no other the comment or questions, then shall we close the sessions?
Yeah. Yes.
Okay. Thank you very much, everyone. Again, I will send the webinar document early next week. Thank you, everyone.
Thank you.
Thank you.
Thank you. Thank you for joining.